So when we're talking about API security, it's crucial to understand that not all APIs are created equal. You've got your RESTful ones, SOAP, GraphQL, each with its own set of vulnerabilities.
Yeah, I've been looking into RESTful specifically because our project uses that.
Good choice for now. But you know what they say, there's no such thing as a secure system, only varying degrees of insecurity. With RESTful APIs, authentication and rate limiting become critical. If you don't have proper rate limiting in place, someone can hammer your API until it collapses.
That sounds like something we should definitely implement then.
Absolutely. Rate limiting is like putting a speed bump on the highway. It slows down attackers, but doesn't stop legitimate users from getting through. And while we're at it, Auth2 is pretty standard these days for securing access tokens.
Right. I've seen auth being used in some projects before.
Exactly. Now here's a fun fact. I once worked on an API where the rate limiting was so strict, it actually slowed down our testing process significantly. The developers were complaining left and right, saying their productivity was shot because every test request took forever to get through.
That does sound restrictive.
Oh yeah, it was a nightmare temporarily. But it also highlighted how important it is to balance security measures without crippling functionality for regular use. Speaking of which, did you check out those new JSON web tokens? They're supposed to be really handy for stateless authentication.
Not yet, but I heard they're quite popular and flexible.
Definitely popular. JWTs are great because they allow us to securely transmit information between parties as a JSON object. This object can be signed using a secret or a public-private key pair. And unlike session cookies stored on the server side, JWTs can be validated by any server in a distributed environment without querying a database or hitting the disk.
That sounds like it could simplify things a lot.
It sure does. Plus, there are libraries available in most languages to handle the heavy lifting of token creation and validation. Of course, nothing's perfect. JWTs still need to be properly secured against attacks like token theft or brute force attempts on weakly encrypted keys.
Makes sense. I'll look more into them then.
Smart move. There's always more to learn when it comes to AP security. It's evolving constantly. Just remember, each layer of defense adds another brick in your wall against breaches. Speaking of which, let's talk about some common threats to APIs. Injection attacks, especially SQL injection, are still pretty prevalent. If you're not sanitizing inputs properly, an attacker can manipulate your queries and gain unauthorized access to data.
Yeah, I've read about those. Sanitizing user input is definitely a must.
Absolutely. Another one is broken authentication mechanisms. If your API allows for brute force attacks or doesn't lock out accounts after several failed login attempts, it's essentially open season for attacks.
That sounds like something we should double check in our current setup.
Exactly. Implementing multi-factor authentication, MFA, can add a significant layer of security. Also, make sure to use strong encryption for all sensitive data transmitted via the API. TLS, SL certificates are a basic requirement these days.
Right, TLS seems like a no-brainer.
Indeed. And let's not forget about cross-site scripting, XSS. If your API outputs unescaped data, an attacker might inject malicious scripts into web pages viewed by other users.
Oh, that's a risk we haven't considered much yet.
It's crucial to sanitize all output from the API to prevent XSS. Use content security policies, CSP, to further restrict what types of content can be executed within your application context. Now, another threat is insecure direct object references, basically, making sure that internal objects aren't directly exposed without proper authorization checks.
So ensuring that every request goes through thorough validation?
Precisely. Every resource accessed via the API needs to be validated against the user's permissions and authenticated status. This helps avoid scenarios where an attacker guesses URLs or IDs and gains unauthorized access to sensitive resources.
Got it. Adding more layers of validation sounds like a good plan.
Absolutely essential. Security isn't just about locking down everything. It's also about understanding the flow of data and ensuring each step is protected appropriately. And don't forget regular audits and penetration testing. Those can reveal vulnerabilities that might otherwise go unnoticed. Speaking of which, let's talk about implementing Auth 2 for secure API access. It's a robust way to manage authentication and authorization in a standardized manner.
Yeah, I've heard it's widely used. What are the main components we need to consider?
Great question. First off, you need to decide on the grant type. For web applications, the authorization code grant is typically the best choice. It provides an extra layer of security by requiring an additional verification step.
That makes sense, especially for web apps.
Exactly. The client app redirects the user to your authorization server where they log in and authorize access. After that, the server returns an authorization code back to your app, which then exchanges this code for an access token.
So there's this middle step where the user authorizes access before getting the actual token?
Correct. This intermediate step helps prevent unauthorized clients from obtaining tokens directly. Additionally, you should implement refresh tokens to periodically renew access tokens without needing to re-authenticate users each time.
Refresh tokens sound useful for maintaining sessions without constant relogin prompts.
Absolutely. They keep things seamless for the end user while still maintaining security. Also, make sure to validate scopes with each request to ensure that clients only have access to what they need.
Scopes seem like a good way to control permissions tightly.
Exactly. Proper scope management can significantly reduce the attack surface by limiting what an attacker could do, even if they compromised a token. Another important aspect is securely storing and transmitting these tokens. Use KTPS throughout, and store them in secure storage, like HTTP, only cookies, or local storage, with appropriate security attributes.
Secure storage definitely sounds crucial to avoid exposing those tokens.
Yes, absolutely. Lastly, consider implementing OpenID Connect, OIDC, alongside Auth 2 for user identity verification. OIDC extends Auth 2 by adding an ID token that contains verified claims about the end user identity.
Combining Auth with OIDC seems like it would provide comprehensive security and identity management.
Definitely. It gives you both solid authentication and detailed information about the authenticated user in a standardized way. Integrating these systems might take some effort initially, but it pays off in terms of robust security and better user experience.